Nitrogen fixation is the process of turning nitrogen from the air into useful nitrogen compounds like ammonia. And the Haber process is a method, a non-biological one of this. Most ammonia produced is for fertilizers, but it can also be used for manufacturing plastics, explosives, and pharmaceuticals. Fertilizers increase crop yields, which is important for world food production. They can cause water pollution and eutrophication. Efficiency can be improved by using an ion catalyst, which speeds up the reaction without increasing temperature so yield is not affected. Alkanes. Alkanes are a family of hydrocarbons which contain single covalent bonds between carbon compounds, saturated compounds. All alkanes have the formula CnH2n+2. Methane, ethane, propane and butane are all examples of these. Alkanes burn to give water and carbon dioxide. Alkane plus oxygen equals carbon dioxide plus water. Alkanes are unreactive towards most chemicals, as the CC bonds and the CH bonds are difficult to break. Alcohols. They have an OH functional group, all have similar properties, and end in -ol, e.g. methanol and ethanol. Alcohols and water are good solvents, but alkanes are not. Alcohols and water have a high boiling point in comparison to alkanes. At room temperature, alcohols are liquids, water is a liquid, and alkanes are gases. Alcohols and alkanes are both volatile, but water is not. Alcohols are soluble in water, but alkanes are not. Alkanes don't react with sodium. Water reacts vigorously with sodium, and alcohols react gently with sodium. Alcohols can be used as solvents in manufacturing as they dissolve many compounds water can't. Ethanol is used in perfumes and aftershave, and can be mixed with petrol to be used as fuel. Sodium plus ethanol equals sodium ethoxide plus hydrogen. Making ethanol and carboxylic acids. Fermentation is one method of making ethanol. This uses yeast to convert sugars into ethanol. It happens fastest at 30 degrees and a pH of 4. It contains a catalyst in the yeast, an enzyme. When concentration reaches 10 to 20%, fermentation stops as yeast is killed off by the ethanol. The ethanol solution can be distilled to produce a more concentrated solution. 1. Ethanol solution is put into a flask below a fractionating column and is heated until it boils. Vapour travels up the column, cooling down as it travels. Anything with a higher boiling point than ethanol cools to a liquid and flows back into the solution. Ethanol vapour condenses as it flows through a condenser and is cooled to a liquid. Biomass. Waste biomass or waste plant parts. They cannot be fermented as they contain cellulose, which yeast can't convert to ethanol. But E. coli bacteria can be genetically modified to convert cellulose in waste biomass to ethanol. The optimum conditions are 35 degrees Celsius and a pH of 6. Steam. Ethene can be reacted with steam to produce ethanol. Ethane, a hydrocarbon, is split to form ethene and hydrogen gas. Ethene reacts with steam to make ethanol at 300 degrees and 70 pressure, with phosphoric acid as a catalyst. Carboxylic acids. They all have the same functional group, COOH, which gives them similar properties. They all end in anoic acid, and they are quite weak acids in comparison to others. They react with reactive metals, alkalis and carbonates like any other acid. The salts formed end in anoate. Ethanol plus oxygen equals ethanoic acid plus water.